Okay. Hello, everyone. Good evening. So sorry for like whatever happened today. Right? There was like complete delay. Okay. I guess you have your WhatsApp group, so you can inform the students there, right? Hopefully, like others can join, so no one misses out on the live session. Okay. Okay. So I'll wait for a minute and then we'll start. Okay. Why? Why delay? Actually, I was not here. I was a little bit traveling. I had something very urgent that got in the evening, so I had to go. I was like trying to come back, but I got the idea before, and like it will take around 1 hour delay. So I tried to inform you during the session, but now I felt like the new community that it should have been there, right? Because there was no way for me to. I informed the batch manager, and I guess the information got passed to you, right? But there was a little delay for that to happen. Okay, no worries. Please be sure that these things won't happen, right? So generally, I am very cautious about the class timings and this schedule, right? Because you all are spending time, you are taking your time out, so I'm cautious on that. So don't worry, right? So plans for today, yes. So we'll have arrays. We'll try to start with time complexity. That is 1 hour of discussion. So I don't think that is going to take too much time. I don't. Okay, there is time complexity MCQ sets they're given, right? So yeah, okay, that's there. Okay, let's start on this. First of all, did you all try on the array questions? Array questions. Is it done? Done the sum question? Okay, great. That's great. How many have tried the like array questions after yesterday's session? Was it easier after solving yesterday's session? Subtraction not happening. Okay, sum done. Okay, subtraction. I guess that's like is little bit difficult than the sum one, right? Someone, Bandana, you have something to say? I see your hand raised. Yeah. Hmm? Negative case. Yes. Triplets question. Yeah. Chalo, tried. Chalo, okay. If you tried, you're having doubt, that's completely fine. I just wanted you all to try it, right? So that we can discuss this and you also have some idea of what this question is. You yourself have tried it. Okay. So the major point of this assignments is to help you try a lot of things, and then we'll anyway solve it, right? If you face doubts. So we can start this. Let me quickly share the screen. Once it's visible. Yeah. How much long? So depends on the question. Few questions I'd say you can stick to like that 30, 45 minutes, 1 hour rule. For easy 30, for medium 45, for hard 1 hour, right? And that's like till when you should try it in focused way. Of think of some solution, try to write some code, even though it's working, not working, that's fine, right? But you should try at least to get some code, right? And then if it's not working, you can obviously use the hints, you can use the chat support, you can use this diamond question is also one remaining. Okay, so we have a lot of questions to be discussed. Okay, I have some MCQs. Okay, let me just.
Hi, sir.
Yes.
Am I audible?
Yeah.
So yes, the previous day you told that you will discuss is Sabare, sir.
Sorry, what I'll discuss? Subarrays.
Sabare.
Subarrays I'll discuss. Yes, I'll discuss subarrays and 2 pointers. So I am still thinking. So we have a lot of things to discuss, and we also think the time complexity thing that's there. So I guess today I have informed the time complexity. Okay, let me write it down first, and we'll accordingly take vote of what you want. Right. So we have in arrays, we have two, three things to do. So one is subarray. We have to solve few questions like sum and subtraction. These are the two questions which we want to solve. Okay. Now this entire thing require around 2 hours. So if I start on this, we'll complete use the 2 hours on this. Then we have a diamond pattern. which requires around, let's say, 20 minutes at least. And then at the end, we have one time and space complexity. These are the things that we have to discuss. Now tell me what's the order you want me to pick up. So let's me think of what we can do. And space triplets. Triplets is also there. The triplet would be in this part area, right? We'll discuss. Okay. So let's do one thing. Okay, I'll do one thing. See, let me do one thing. So let's try to complete these two for now. Okay, these two for now, because why I'm telling you we'll try to complete time and space, and then we'll pick diamond, and then we'll go to arrays question. See, on arrays we have done questions. I have explained you the concept. Subarray is not like a specific new thing. It is just array. Okay, just a way of solving problem. I'll explain you that in the end. Okay. Regarding the questions, if you have particular doubts on questions, you have support of anyways doubts session that you can use, or if we can use the revision sessions. If any questions get left out, we'll cover that. Okay. Today we have a stitch of like 1 hour less time, right? So we'll try to stick to this. If we complete early, then anyways we'll use the time to solve more questions on arrays. Okay. So let me start with time and space. I'll not take more than an hour to complete it, and then we'll go to these questions. Okay. Okay, so listen to me now. Like now, I want your 1 hour very focused time. Okay, so listen to me very focused. This is going to be a very interesting discussion. Okay. No, sorting we have not started even. Sorting is there at the end. Right? So sorting, there is a lot of time to go to sorting. Okay. 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 So what is this time and space complexity? Okay. So till now we were writing code. Okay, so I used to write code, and we were writing code, right? Used to write code, and I was writing code, you were writing code, and there can be different logic. There can be different logic of solving the same problem, right? So for example, yesterday we saw one logic where I solved a question by writing a nested loop, finding out the distance between two even positive number, right? We found out the distance between two even positive numbers. So we found out the distance between two even positive numbers, and we were doing it in two ways. One was we wrote a nested loop to get this work done, right? And another way was we wrote a single loop, but there was like some if else, single loop with some if else. Both of them were doing the same work, right? Both of them were doing the same work. Almost everything was running same, right? So for the first number, we are finding out the next number, which was the next even number to it, and then we are stopping there. For the next even number, we are trying to find out the next even number, and we were stopping there, right? So this is what we were doing. Achha. Now, how do we actually measure time of any particular code, right? So whenever we write code, the most important parameter to measure how good our code is, right? The most important parameter to measure a good code is time. Okay. There are other constants as well, like what is the amount of space it is using, whether the logic is clean, whether it is understandable, easy to understand. All those things are there. But the most important thing is time, right? So for example, let's say I write a logic which is very easy to explain. I can explain you very well. You can explain that logic in the interview very well. But that logic is taking a way lot time than a very complicated logic might take. Okay. So logic might look, logic is very clean, logic is very simple, but it is time taking. Okay. And a logic is very complex, and it takes less time. Okay. So we would any day prefer this logic, even though it is difficult to understand, but this takes less time. Okay. I'll give you an idea of how important time is. So Amazon like recently published one of the Jeff Bezos himself talked about this. For every 1 second delay, right? Every 1 second delay that they used to have in their site, maybe the initial load screen, if you are trying to visit Amazon.in and you're seeing the site getting loaded after 2 seconds or 3 seconds, or maybe let's say after you are put something in your cart and then you are trying to place the order. So you are seeing some delay or some you are seeing some amount of time which is taking for you to click on the place order and actually make the payment screen load or so. So for every 1 second delay, Amazon used to lose millions of dollars. They get millions of dollars. because users are so used to like having things delivered to them very quickly, that they move to some other app, right? They simply go to some other app to place the order, right? So for example, if you try to search something on Google, and Google, let's say, start taking 5 seconds to search, you'll immediately switch to something like Bing or ChatGPT, or you'll go to Yahoo. Will not wait for Google to give you the result after 5 seconds or 10 seconds, right? So that's why Google always have to write something better, and still give you the time, still give you a search result in 0.5 second or 0.6 second or something. Okay. So every software, even though it is developed already, we need to keep on improving the logic so that the software takes less amount of time. And if the software is developing, right, if we are developing a software, so we have to ensure that whatever logic we are writing takes least amount of time to run right now. Okay. Okay. Now, how do we basically compare time? Okay. So first thing, in terms of software, time is very important. We understood this, how impactful it is. We saw Google search, we can see of Amazon, and practically any other software that you will be working on. The major constant while writing any logic would be time. And you have to think of how this logic or how this particular feature or this particular problem will be solved in least amount of time. Okay. Now, how do we actually measure time in terms of code? So we don't measure time in while writing code. So let's say we write a loop, right? We wrote a loop and then we wrote another loop inside it. Okay. Okay. And then we did the same problem by writing a single loop. Now, how do we measure the time that is taken by this thing, and how do we measure the time that is taken by this thing? So do we actually measure the time in actual terms? Like, will we say, okay, this loop is taking 0.8 second and this loop is taking 0.5 second, so this is better? No, we actually don't measure it in actual terms. Okay. So whenever I'll talk about space and time complexity, we'll never measure time in it absolute term like seconds or minutes or hours. We'll not do this. Okay. So then how will we measure? We only know one way to measure time till now is seconds, minutes, or hours, right? We don't know any other way to measure time. Okay. So we'll not use this format. We'll use an approach known as number of lines of code. Okay. Okay. Now, what is this number of lines of code? So we can write certain line of code, okay, which can take a constant amount of time. So for example, we will assume that all these operations. So for example, like we write a plus b or a minus b, or let's say system.out.println a, right? We check if a is greater than b, right? Or we write any statement like of a single for loop declaration, or like int a equals to 5, right? All the statements that we write, okay, these takes constant amount of time. All these statements that we write are taking constant amount of time. Okay. Let me just erase the loop from here to avoid any confusion, because the next thing is related to loop. Okay. So we'll assume all the statements that we are writing, any single statements will take a constant amount of time. Now, what is this constant amount of time? Is it some fixed time like 0.0001 second, or like 1 millisecond, or 0.1 millisecond? Is it fixed? No, it would depend on the machine on which you are running. So for example, a very simple example, easy to understand. Let's say I have a very like a hi-fi machine, which is like, let's say 16 GB, 4-core CPUs, right? A very good processor, let's say i9 processor. Okay. And then I have one very like old machine, which is like 4 GB RAM, which is just 1-core CPU, right? Which has a like i3 processor. Okay. So I have these two machines on which I am running the my code. Okay. Now it is obvious that this machine would be able to execute the code faster as compared to this, because this machine has got more hardware capability than this machine, right? So this constant amount of time might vary from hardware to hardware, right? Might vary from hardware to hardware. If you run the same code in a very high processing machine, it would yes, yeah, you can think it in terms of clock speed, you can think in terms of core CPUs that you have, you can think in terms of the processor that you have, right? Or simple example, let's say if you run the same code in my machine and you run the same code in a supercomputer, so the supercomputer is definitely going to run it fast, right? So this constant amount of time would generally vary from machine to machine. right? So some machines, for some machine, it might run this instruction in, let's say, 0.1 millisecond, and some other machine might take like 0.0001 millisecond to run the same line. Okay, so it might vary from machine to machine. So that's why I'm calling it as constant amount of time. Okay, so all the statements that we'll write will take constant amount of time. Okay, now understood what is constant amount of time. So all these statements, right, a single statement, which is a just one statement, we assume that this is a one unit statement and it takes a constant amount of time to run. This constant amount of time might vary from machine to machine, but we'll assume these all operations are running in the same amount of time. For simplicity, we'll not assume that addition is taking more time, subtraction will take less, println will take a little bit more. No, we'll assume everything works on the take the equal amount of time to make it our life calculation easy. Okay, so we'll take that every line of code runs in a constant amount of time, and this constant amount of time might vary from system to system, and it is like a system dependent thing. Okay. Okay, understood this part? Clear? Any doubts over here? No? Okay. Okay. Now, what is this constant amount of time? Do we have some measurement, something that we can use? Yes. So there is one thing that you need to remember. See, all the compilers that you use online, right? Be it like all the sites that you have heard of, like Lead Code or all the sites that you have used ever, right? Lead Code, Code Forces, a Code Chef, right? Hacker Rank, Hacker. So your online exams, your company exams that you are going to appear are also going to be in these sites, right? It might be on our platform as well. It might be on Hacker. Okay, Ajit, I'll come to that question. I'll come to whether this is going to cause any difference. Okay. Hacker Earth or Hacker Rank, mostly this, or you might have AMCAT or Mittel, some platform like this, which are just for giving exams, right? So there are a lot of similar sites on which you might be giving your exams, and we have configured our site also in the same way. So whatever constant you are seeing over here, will get the same kind of experience while giving your exams, right? Now, what all these sites have common, they follow approach. They have defined all of the sites together have defined, right? Every other site is configured in the same way that they run 10 to the power 8 lines of code per second. Okay. All the systems that they have in behind, which is actually running your code when you submit the code, they run this much amount of code, which is 10 to the power 8 lines of code per second. Okay. So if you write 10 to the power 8 lines of code, is it exactly 10 to the power 8? If I write 10 to the power 8 lines plus one line, will it take more than 1 second? No, it doesn't work this way, right? So this is a very, so okay, I'll give you some idea about how small the actual one line of code is. Okay. So I told that it takes 10 to the power 8 lines of code runs in 1 second. Okay. Now, how much amount of time will one line of code take? 10 to the power 8 line takes 1 second. So one line of code, how much time it would take? 1 divided by 10 to the power 8 seconds, right? Correct. So one line of code is going to take this much amount of time. But how much time is this? 10 to the power minus 8 second, or we can say 10 to the power minus 5 millisecond, or we can say 10 to the power minus 2 microsecond. Very small, very small time, right? If you write 0.00000001 something, it will come, and that much amount of time. Like if you divide 1 second into 10 to the power 8 times, right? Not 8 times, 10 to the power 8 times, right? It is going to take 1 unit of that time to run one line of code. So each line of code is like actually very negligible amount of time. You can consider it almost a negligible amount of time that it takes to run the one line of code. Okay. And all these sites are configured in the same way. Even our platform is also configured in the same way, right? That we also support the same thing, 10 to the power 8 lines of code per second. So now whatever code you write, right, you have to stick within this, and the time constant for questions you get to solve is 1 second. So you have to solve the question within 1 second. Okay. So that you have a constant to solve the question within 1 second. Now you have, like, no matter however you write, you cannot breach this. How will you ensure that it always runs within 1 second? If the number of lines of code that you have is in less than 10 to the power 8, it is always going to run in 1 second. If it is greater than 10 to the power 8, as it keeps on getting higher and higher, the time would get higher. Okay, and then it won't work for that time. Okay, so let me give you an example of how bad more than 10 to the power 8 can be. Okay, so let's say the machine that we are using is configured to run 10 to the power 8 lines run in 1 second. How much amount of time would 10 to the power 9 lines of code would take? Think if running 10 to the power 8 lines takes 1 second, how much time 10 to the power 9 lines would take? It's not 2 seconds. See, it is 10 into 10 to the power 8 lines. Okay, it is 10 into 10 to the power 8 lines. So 10 to the power 8 lines takes 1 second. Okay, so for running 10 into 10 to the power 8 times, 1 second plus 1 second plus 1 second, how many times? 10 times. So how much time it would take? 10 seconds. Understood how it is 10 seconds? So if 10 to the power 8 lines is taking 1 second, okay, so it is 10 into 10 to the power 8, right? 10 times 10 to the power 8. So each 10 to the power 8 takes 1 second. So then again 1 second, then again 1 second. So it would take 10 seconds. Acha, think it in this way. Acha, so if you add 10 to the power 8 10 times, what you will get? If you add it 10 times, will you get 10 to the power 9? Yes. So each 10 to the power 8 is taking 1 second. So it is also 1 second, it is 1 second, it is 1 second, it is 1 second. So if you add 1 second 10 times, the time gets added, right? In the normal addition gate. So it is 10 seconds. So 10 to the power 8 takes 1 second. And if you go to 10 to the power 9, it is 10 seconds, right? And by following the same logic, 8 is 1 second, 10 to the power 9 is 10 seconds. 10 to the power 10 would be 100 seconds. 10 to the power 11 will be 1000 seconds. Understood? Why it is 10 seconds, why it is 100 seconds, why it is 1000 seconds. Yes. Now, will you ever wait a logic to, if it takes like 100 seconds, it is like 1 minute 40 seconds. If the Google search takes 1 minute 40 seconds, will you wait for it? 10 to the power 8 into, no, 10 to the power 8 into 10 to the power 8 is not 16, it is 10 to the power, yes, 10 to the power 8 plus 8, 16, yes. So now it would be like 10 to the power 8 times. Why it is expressed in this way? Asha, tell me, how many of you got this calculation, 1 to 10 seconds? How many of you understood this calculation, this step? How many of you didn't, right? Tell me that one, that part would be easy. Did not. Okay. Achal, think it in this way. Dekho. 10 to the power 9 is nothing but 10 to the power 8 added 10 times. Yes or no? First, tell me this step. Is it is this step correct? If you add 10 to the power 8 10 times, will you get 10 to the power 9? If you add 100 10 times, will you get 1000? Same logic, right? If you add 100 10 times, right? So you get 100 into 10, right? Same way, if you add 10 to the power 8 10 times, you get 10 to the power 8 into 10, which is 10 to the power 9. Now, each 10 to the power 8 lines of code takes 1 second. So how much time will 10 to the power 8 lines of code will take? It is 10 seconds. So let's say this is 10 to the power 8 lines of code. And then again, you write 10 to the power 8 lines of code. And then again, you write 10 to the power 8 lines of code. So on. So this is taking 1 second. This is taking 1 second. This is taking 1 second. So on. So your entire code is going to take 10 seconds. Yes. So the base is 10 to the power 8. We have like 10 to the power 8. I'm just trying to show you how bad it gets once you go to 10 to the power 9 and 10 to the power 10. Because it is drastically very high, right? The time is drastically increases to 10 seconds, 100 seconds, 1000 seconds, which is not reasonable, right? No compiler is going to accept such solution. You can generally think, right? If you have a software like say Google search tomorrow starts giving you a result in 100 seconds, will you wait for Google search to give you the result, or you'll switch to some other browser? Obviously you'll switch to some other search engine. You'll never wait for any site. You will feel that something is broken in the site if it doesn't give you the result in 1 second. Let's say tomorrow you come to your Accio portal and you refresh it and you are not seeing the Accio page for 1 minute. Will you like wait there? You'll just put a message in the Slack to your batch manager, said this is not working. The site is down. I think I'm not able to access the code. I'm not able to access the class, right? So no, we as users are like, we can at max wait from 1 to 2 seconds, but 10 seconds, 100 seconds are a lot, right? Yes. So you can write it as C. So this is like nothing but you can write it in this form 10 into 10 to the power 8 or 10 into 1 second, which is 10 seconds. Okay. Understood this, how this is coming 10 seconds. Now same logic, you can get 10 to the power 10 is 100 seconds and 10 to the power 11 is 1000 seconds. Now why specifically 10 to the power 8? Because see, this is like a very like normal compiler around which has around 4 GB RAM and 2 core CPUs. I guess this is like the specification. 4 GB RAM or 2 core CPU or 1 core CPU, something around this, which is like which was the most general compiler, or which is the most generic device that is there with all the users, right? So we'd say ki most of the users which use the site, or most of the users that have access to internet have their devices are in the range of this particular configuration, right? So that's why, and this such kind of configuration runs around approximately 10 to the power 8 lines of code. Okay. So that's why all the sites wrote this logic that for now we'll have 10 to the power 8. Okay. Later assume ki all the devices got upgraded. Since we are upgrading our devices, earlier we used to have just 1 GB RAM, right? Now we have better RAMs. We have 4 GB, 8 GB RAMs. We have 16 GB. Let's say in future everyone has access to 32 GB RAM, and this is the most common device that everyone uses: 32 GB RAM and 8 core CPUs. Let's say, or 4 core CPUs. Okay. So all the sites will someday change their configuration so that they can run 10 to the power 9 lines as well in 1 second. Okay, they will upgrade their systems which are running the code. But for now, that is 10 to the power 8, and that is not going to go away soon. Okay, because this hardware upgradation requires a lot of time. It happens gradually over time, and it is not like overnight everyone will go and buy a new device, right? We will not use a tomorrow. If I say that if this new device is going to give you high speed, you're not going to buy that, right? You'll wait for some time until your current device gets old, and then you actually need one new device, then you will buy it, right? Till that time we need to stick to this. Okay, understood? Suppose now if we have supercomputer, it only runs that many lines per second. If we have this compilers, no. So it is not compiler dependent, right? That's what I'm telling. It is machine dependent. So if you run the same code in a very supercomputer, it will definitely run your code faster, right? Okay. Okay. So this was a little bit about time, how it is measured. What is the standard of 10 to the power 8 lines of code that runs in 1 second? What happens if you go to 10 to the power 9, 10 to the power 10, or 10 to the power 11 lines of code, right? How drastically your time differs, right? And for now, we'll follow this approach. Now, there is one simple question that you might be getting. So this is already a very high number. 10 to the power 8 is like a very large number that you are talking about, right? This large number, we never exceed 20, 30 lines of code, or let's say 100 lines of code for simplicity, or let's say 500 lines of code. We'll never exceed 200, 400 or 500 lines of code. So for now, it is of no use to us. So we can relax for now, right? All our code is going to be within the time limit. No, you all are actually writing code that exceeds this limit. Okay. So how are we writing this? So we are using loops, right? So all the things apart from loops that you're writing, like if else condition, switch case, ternary operator, initialization, variable assignment, relational expression, logical expression, all of them work in constant time. Okay. All of them, let's say, is constant. Okay. For similarity, all of them are constant time. Okay. But this loops, when you write loop, right, what happens is you are writing int I is equals to 1, I is less than equals to 100, I plus plus, right? So is this 1, 2, 5, 10 lines of code? No, this is this 2 lines of code when you do let's say count plus plus. No, this is not 2 lines of code. This is 100 lines of code. This is 100 lines of code because equivalent to 100 lines of code. So this statement is going to run 100 times. Okay. Chalo, let me show you this example, and of this theory, let me just show you a practical example. Okay, by writing a loop. So let's say I write a simple loop, I is equal to 1, I less than equals to 100, I plus plus. Just a loop. Okay. Y 10 to the power 8 into is not equals to 2 seconds. 10 to the power 8 into 10 to the power 8 is not, how can it be equals to 2 seconds? See, 10 to the power 8 into 10 to the power 8 is 10 to the power 16 lines of code, right? If it is 10 to the power 8 plus 10 to the power 8, this is 2 seconds, right? ये 2 second होगा, but ये जो 10 to the power 16 है ना, so ये 2 second नहीं होगा, right? ये 10 to the power 8 seconds होगा. Yes, when you add it, time gets added. अगर multiply करेंगे तो time multiply नहीं होगा, right? Multiply कर रहे तो add नहीं होगा ना time. Got it? So ये 1 second और ये भी 1 second लेंगे, so that is 2 seconds. But you are doing like 10 to the power 8, 10 to the power 8. You are adding this 10 to the power 8 times. How can this be 2 seconds? So this is 1 second plus 1 second plus 1 second for 10 to the power 8 times. So that is 10 to the power 8 seconds. This would take almost around 10 to the power 8 seconds. Understood? Okay. देखो टाइम ऐड होता है, राइट? टाइम वर्क्स इन अ नॉर्मल एडिशन में, राइट? कि फॉर एग्जांपल लेट्स से you walk to like you walk from A to B, you walk from A to B and it takes around, let's say A to B, ठीक है, let's say you walk from A to B and it takes you around, let's say 1 minute, ठीक है, and it is fixed, right? It will always take 1 minute, ठीक है. So now if I tell you to walk from A to B and then B to A, then A to B, okay, you have to do this, then this, and this. How much time will you need? This will take 1 minute, this will take 1 minute, and this will take 1 minute. So total 3 minutes, right? So time works in a normal addition way, right? If you do the same thing. So machine will also take the same thing. So machine told that it will run 10 to the power 8 instructions per second. Okay. Now if I tell it to run 10 to the power 8 plus 10 to the power 8 plus 10 to the power 8 instructions. So it will take 1 second plus 1 second plus 1 second. So it will take 3 seconds. Understood? Yes, no? Okay. Yes. Okay. Now let's come to here. Let's come back. System dot out dot println. Okay, let's print hello. And if I run this, what is going to happen? See. So you're going to see hello world instantly, right? No changes. So if I run this loop for 10,000 times, and if I run this, is it 10 to the power 8 lines of code or number of operations? So it is same, right? Lines of code or number of operations. I refer it as lines of code. You can refer it as number of operations. It's same, right? Okay. I'll talk about how number of operations lines of code it varies. Just give me a minute. So 10,000 still works fine. We get the result. Let's make it 10 to the power 6. Okay. Still works fine. You immediately see the result. Okay. Now this online GDB compiler is compiled for a little bit higher. That's why you see this this compiler is working faster than any other compiler that's out there. Okay. All the other compilers that's there, they are configured for 10 to the power 8. So if I run it as 10 to the power 8 or even 10 to the power 9, it still works because this is configured for a little bit higher side. Okay. So the machine that it's using is a little bit higher. So now I'm using 10 to the power 9. Okay. See. Now still we are seeing the result almost instantly, right? So we don't see any significant difference for even 10 to the power 9. We almost see the result instantly. A little bit slighter, more time, but almost instantly, right? So if I run it, right, it's not taking that significant amount of 10 seconds or something which we can observe. Now let's make it 10 to the power 10 and now run it. Okay. Now this is too large to be an integer. First of all, we get that error. Okay, chalo, let's convert it into long. Let's write a L at the end of it to make it a long number and now run this loop. Okay. Now see, Now it is actually waiting. You are seeing that wait, right? Now let me run this again and look, this time look at it carefully, right? You'll see some wait that it is doing. See, it is waiting. It is not giving us the result. It is waiting for some time. Then it is printing hello world, like around 2-3 seconds, roughly. More than that. Now, if I add one more zero, now you'll see a very significant wait that it will do. See, now it will almost wait for 10 times more than it waited for the previous time, right? To give you the result. It's still waiting and it's not giving you the result because this loop is taking time to run. Okay, it is taking time, and we are still not getting the result. See, we are still waiting to see the hello world. It's still taking time, right? So whatever time it took previously, like 2 seconds, 3 seconds, whatever it took, right? It will take around 10 times of it because we added 1 0, right? Now, whatever time it will take it now, right? Let's say 30-40 seconds, 30 seconds around, roughly around that time. Okay. If I add one more zero, then it will start taking 10, 10 more seconds, which will be 10 times of it, which will be around 300 seconds, roughly around 5 minutes. Till 5 minutes, you might not see any output. Okay. Now, until this output comes, let me let me give you idea of what is happening. So first of all, this compiler is a little bit different. Okay, so don't miss it. Don't compare it with the online compilers like our Ekeja platforms or the compilers on LeetCode or HackerRank, because they are configured in a different way. They will not work for more than 10 to the power 8 seconds. Okay. Anything that you write about 10 to the power 8, like 10 to the power 9 or 10 to the power 10, you might see errors written there. Okay. So see, now it's still we need more examples. It will take more time. Yes, if you need more examples, it's going to take more time. Yes. Okay. Understood. Got the basic idea, right? So if you start increasing this number of iterations of the loop, your number of lines of code is increasing, and that's where the time is also increasing, right? Your time increases because time is getting added up, and it will keep on increasing, and there might be some point where it will stop showing the result, and you'll just be waiting. And your online compilers will not going to wait for this time. They have a constant of you should give them the result within 1 second. Okay, and they've given you one constant that you have to write 10 to the power 8. Now, one simple thing over here. Okay, by the time this results comes up, let's discuss something. Okay, so let's say we have written a logic of 10 to the power 8. Okay, you in a single loop. That's fine. You can write it using single for loop. Or what if I have written a nested loop? The outer loop is running from 1 to 10 to the power 4, and the inner loop is running from 1 to 10 to the power 4. Okay. How many lines of code is this? Whatever statement I have written over here, let's say one statement I have written over here. How much lines of code is this? Think it carefully. Powers multiply नहीं होते. So it is 10 to the power 4 into 10 to the power 4 lines of code. How much is this? This is 10 to the power 8. Power gets added actually. 8 powers add होते हैं. So in multiplication, let's say you have 10 to the power x, 10 to the power a into 10 to the power b. Okay. So the final result is 10 to the power a plus b, right? You the result. The powers does not get multiplied. So 16 this is not going to be 16. The powers is going to get added and it's going to be 8. Understood? So when you have two powers, you multiply them, the powers actually gets added, and the final result is this addition of power, it does not get multiplied. So you can think it of like this. For every iteration for the first loop, you have 10 to the power 4 lines. For second iteration, you have 10 to the power 4 lines. For third iteration, you have 10 to the power 4 lines. So that's like adding 10 to the power 10 to the power 4 times. Right? If the base is same, then you simply add it. Okay? If the base is same, then you simply add it. Understood? Okay. Achha. Now one simple thing, on this one. So what is this? If I give you 10 to the power 4 cube, how many lines of code is this? It is 10 to the power 12. Now it gets multiplied, right? At this point, it gets multiplied, but if you are actually multiplying these two, the power gets added. This is how power addition works, right? Power logic works. Okay. See, still we are not getting the result, right? It's almost 3-4 minutes, but we are still waiting for it to give the result. Okay. So let's discuss something in the meanwhile. Right. So in the portal also you get some idea about the time limit that is that your code is taking, the time your code is taking, and what is the time limit within which your code should run. Right. Now I'll explain you more about how you can use in the portal to before even running, you'll be able to know whether this code is going to work or whether it is not going to work. Okay. By just seeing the code, you will be immediately able to tell what's the time wise it is fine or it is not fine. Okay. So now, okay, we understood this, that we okay, how powers work, how the lines of code works, how it works for nested loop. Now, one simple question is, how strict is this 10 to the power 8? How strict is this 10 to the power 8 lines of code? Right? If I write 10 to the power 8 lines of code plus one line of code, is it going to exceed 1 second? Right? Does it actually exceed 1 second? If I write 10 to the power 8 lines of code plus 2, will is going to exceed 1 second? No, actually, this is not very strict. इतना strict नहीं है कि 10 to the power 8 exact पे stop हो जाएगा. It is not going to, it doesn't work that way. ठीक है? Why? चलो, I'll give you a simple idea. Think it like this. ठीक है? कि now we got the result after around 4 minutes, 5 minutes. ठीक है? Finally it gave the result. ठीक है? अच्छा. Don't ask me to add 1 0 and run it. Then it will take around now it took 300. Then it will take 3000 seconds, which will be roughly around 50 minutes, I guess. So I'm not going to run it. We won't get the result. Okay. So I'm not going to add one more zero to it. Okay. So how strict is this 10 to the power 8 lines of code? Does it actually is very strict? So let's discuss this, right? So we have one line of code and it takes around 10 to the power minus 8 seconds, which is like 10 to the power minus 2 microsecond or 0.01 second microseconds. Very small time, right? Very small time, right? So small that it's almost negligible, right? Almost negligible, very small amount of time. Right now, all the compilers, when I told this is 10 to the power 8, this is not like very hard and fast that they work only on 10 to the power 8. You cannot write anything exceeding 10 to the power 8. So all these compilers works very fine. Like if you write something around 3 into 10 to the power 8, or even 4 into 10 to the power 8, or even at sometimes even 8 into 10 to the power 8 or 7 into 10 to the power 8 would work. Okay. This kind of logic works. But if you write 10 into 10 to the power 8, then it is like equal to 10 to the power 9, which is not work. This doesn't work. At 10 to the power 9 doesn't work for in any one of the compilers, but it works for like 2 into 3 into 4 into, and somewhere here there is a boundary, right? Like 3 into 4 into 5 into 10 to the power 8, or sometimes 7 into 10 to the power 8 also might work, where there is a boundary beyond which it is not going to work. Okay, so like 10 to the power 8, 9, there is like very edgy, it might not work in some compilers, and 10 to the power 10, like 10 into 10 to the power 8 is definitely not going to work. So what I'm saying is, this 10 to the power 8 lines of code, which is given to us as restriction, is not very strict that we have to write anything less than this. Right? Let's say you wrote a loop which is 10 to the power 8 lines of code. Okay, I equals to 1, I goes from 1 to 10 to the power 8, which is 10 to the power 8 lines of code, right? And then you have not written a nested loop, you have written another loop right outside this. So it also runs from 1 to 10 to the power 8 lines. Okay. So how much time is this? So this is 10 to the power 8 lines, and this is 10 to the power 8. So you can say it is 2 into 10 to the power 8. So this is fine. This still works within 1 second restriction. So this is fine. This does not give you any errors or any time related issues. Okay. Okay. So this won't give you error. Even 3 into 4 into won't give you errors. That is also fine. Okay. Okay. So even that also doesn't give you error. That is also fine. So this is not very strict. It is little bit lenient, but yeah, you cannot expect if you write 10 such loops, it will still work within that time portion. It will, it might not work, right? So there it will Yeah, so 10 to the power 10 is like, this is like, you'll assume that this is never going to work. So 4, 5, 6, up to 6 such loops, 5 such loops, even 7 such loops might work. Right, there is like very edgy. You might get a time like 0.99 or something like that, or 0.89, something like that, very close to 1 second. So you'll be very close, but still might work. Okay, but once you exceed this, you are going to see issues, and it is not going to work in 1 second, and compiler is going to give that time limit exceed error. Okay, now we understood this, we understood all this. Now, how do we actually measure it, right? So in order to measure it, there are different to do compiler like lead code uses too many machines to compile. There are lakhs of users. Yes, so there are like multiple machines which are running at the same time. So your code will be running on one machine, then there might be some other person's code which might be running in some other machine. So they have multiple machines running it, right? Because multiple users are submitting at the same time. You also might see errors, right? Like for example, in our system, we have prohibited you to submit run multiple submissions within 15 seconds, right? So you cannot submit a code, you cannot submit an answer within 50 seconds 2 times, right? You cannot do that, right? Because there are multiple users that are running it. Even lead code has done it. You cannot make more than, I guess, 5 to 6 submissions within like 1 minute, right? You cannot do that. If you do more than 5 to 6 submissions within 1 minute, then you get that error that you have made 5 submissions, please wait for 1 minute and then make another submissions, right? uh, So your code is actually running on a machine, right? And that machine would take time for 1 second to run your code. So same time, a lot of other users also submitting. So we have a lot of machines in place. Same goes for other sites, but there is some limit that they give you, right? Because you'll keep on continuously submitting, and that might be a lot of burden for that machine to run the code, and other users might not get the chance to run it, right? Or everyone will see a very slow system, or we might need too many machines. So for example, if we create, like say, 100 machines or 1,000 machines to run your code, and you can submit every time, those machines will be just lying around when no one of them is using it, right? In the peak hours it will be maximum, and then in the non-peak hours no one is using them, right? So balance out all these things. Every system does this kind of things where they keep a delay, or they allow you some restricted numbers of submissions, all this. Okay, now how do we actually measure it? What are the different ways to like measure it? So we have something known as asymptotic uh, time complexity, and here we measure it in terms of 3 parameters, 3 different ways. One is known as theta, one is known as omega, and one is known as big O. Okay, I'll not talk about the theta and omega for today because it might be too much to depth today. I'll talk about them in a while, right? They are not needed. You just need this one. You'll just be using this complexity forever. So you just need to know them as theory. Okay, since this is just the theoretical part, I'll cover it at somewhere later. Okay, somewhere when we'll do a revision session or sometime, we'll cover this part. But for now, I'll cover the important one, which is BICO. Okay, so how do we actually measure time? What is this big O notation? Okay, so in terms of big O notation, we represent the time in form of big O. Okay, so we represent big O of 1 as constant amount of time. So the time that I was talking about, right? So every statement, every line of code that you write runs in a constant amount of time. Now that constant amount of time is this big O. Okay, so that constant amount of time that every code takes is this big O time complexity. Okay, so we represent it as big O of 1. Okay, this big O of 1 is that time complexity that I'm talking about, constant line of code. So if you ever get a question like this, how much time will this particular line of code take? So we simply tell it big O of 1. Okay, this takes big O of 1. How much time will this line of code take? 5, 6. This is big O of 1. Okay, even any number, any constant number multiplied to this big O of 1 is also big O of 1. Okay, if this number is very small, right? So we tell it as 10 lines, 50 lines, 100 lines. Also, we tell it as big O of 1 complexity because it is constant amount of time. Okay, acha. Big O actually represents something else as well. Okay, it's not except loops. I'll talk about loops. So there is one very common interesting question that you get from here, and this is like one of the most asked questions, right? In interviews, you'll get like questions like this. Okay. And it would be asked that what is the time that this code takes? Okay. What is the time in terms of big O? Like your in interviewer is like a general assumption that you will be telling the time in big O complexity. Interviewers is also ask you the time in big O complexity, right? Really, anyone ask you in theta or omega. Okay. So you'll assume that if he's asking you in big O terms. So what is the time complexity of this code? So so the correct answer for the time complexity of this code is also big O of 1. Now, how do I justify that this code is big of 1? This is running for 10,000 times. This is actually equal to 10,000 lines of code, right? This is 10,000 lines of code. How do I say it as big of 1? Okay. See, so constant time, what does constant time mean? Constant time means a known time, right? So constant time means known time. That means if you run this code on any number of times on the machine, right? Any number of times on a given configuration machine, it is going to take that same amount of time. Let's say this code takes 100 milliseconds to run. Okay. No matter how much you run it, it is always going to take the same amount of time, 100 milliseconds, which is fixed, right? So constant time means some fixed time which the machine is going to take to run this code. No matter whatever you do, this code is going to run in that much amount of time, which is fixed. So it also stands for big of 1, not just stands for constant amount of time, that single statement. It also stands for if any code is taking a fixed amount of time to run. Okay. It also is represented by big of 1. Okay. So big of 1 is the notation for representing any constant amount of time, for example, like this, for a code example like this, which or any fixed amount of time. Now, yes, now that's a valid question. I knew that you will be asking this. Sir, if you are telling this, how much time will this take? So will you still say that this is also constant amount of time? Yes, this is also constant amount of time. Will you say this is also constant amount of time? Yes, we would say this is also constant amount of time. Now, what is this constant amount of time or fixed amount of time that this code is going to take? The fixed amount of time that this code is going to take is not 1 second, it is 100 seconds, right? So it is still big O of 1, but this doesn't work in 1 second. Did I ever mention that big O of 1 is always less than 1 second? No, right? Big O of 1 is never like, it's not always less than 1 second. Big O of 1 is simply a representation of constant or fixed amount of time. Okay. It simply says that this line of code or this snippet of code is going to take constant or fixed amount of time. Okay. And it is not going to vary no matter you run 1,000 times or 10,000 times the same code in the machine. Okay. That time is fixed. Okay. So this is like a very general assumption that everyone makes, that big O of 1 always represents a single statement or a constant time, which is one line of code. Right. So big O 1 doesn't represent one line of code. It represents time. Okay. So this is a representation of time complexity, right? This is not representation of lines of code. Huh. Is there any code which changes time when we run it? Yes, there is code. And for that, this time complexities are actually defined. Now, what is a code that would change its time every time we run? So if I write let's say a normal line, that would take always the same time. But if I write a loop, let's say, which runs for n times. Now, what is the time complexity of this loop? So we don't know. We actually cannot guess the time complexity of this loop until we know the value of n. So the time complexity of this loop is big O of n. We simply say that time complexity of this loop is big O of n. The time is dependent on n value. Now, if you give it a n value like 10 to the power 8, you're fine. You'll get up to like 1 second of time. If you give it over 10 to the power 8, like 10 to the power 9, 10 to the power 10, you're not going to get 1 second. So this code is not going to run. Okay. This code is also not going to run, but this you can directly say by looking at the code. This you cannot guess directly say by looking at the code. You have to look what is the value of n going to be. Right. Now, what are the different variations of it? I'll talk about the variations. So what are the different ways that this time complexity would vary? So there are a lot of things, like there are a lot of standard ways in which we measure. So this is a big O of n loop, right? Easy to understand, simple big O of n. What if you say that, okay, So what if I have two loops? Sorry. We have one loop inside which we have another loop. Okay. This is running from 1 to n. How much lines of code is this? N square. So it is big O of n square. So now it is dependent on big O of n square. Achha. Now look, when I say the time complexity of this loop is big O of n square, what does this mean? So this means that if you have, let's say n value is 10 to the power 4. So what is the number of lines of code going to be? 10 to the power 4 square, which is 10 to the power 8. Is it going to work? Yes, it's going to work. If n value is 10 to the power 5, or if n value is 10 to the power 6, is this going to work? Let's check. 10 to the power 5 square is 10 to the power 10. No. 10 to the power 6 square is 10 to the power 12. So this is also big no. So these two are not going to work, but this is going to work. So if your largest value of n is 10 to the power 4, you are still okay, right? But if your largest value is 10 to the power 5, 10 to the power 6, you are not okay. It's not going to work. Okay. Achha. Is there any other variations? Yes. Now there can be any like, let me just show you this. So if I write one more loop over here, or we call it a scale. What is the time complexity of this one? This is n cube. Now, what is the n value, highest n value for which this loop is going to work? So if n value, highest value is 100, right? It will work, right? So it will be 10 to the power 6. If it is 1000, so it will be 10 to the power 9 and it will not work. Right? It will still work for 500. So for 500, you will get roughly around 500 into 500 into 500. That would be still less than that, right? So 500 also it will work. Yes. Is it, did I write 0? It is O. It's 0, it's O. It's O. That's why I've written, right? Big O. It's not big 0, it's big O. It's read as big O. Okay. Okay. Now there can be any polynomial, right? Now you got the idea of if it is changed, right? And n square, n cube, n to the power 4, n to the power 5, n to the power 6, and you can keep on going that. Now you will get the idea if your complexity is this, what's the largest value of n for which your code is going to work. Now, one simple question that you might be getting is, sir, you explained this much and we did understand this, but how are we going to know this largest value of n? Actually, it's given in all the questions. Okay, if you go back and see any question, let me just open any one of the questions from here. Okay, let's open a question that we solved. So yesterday we solved some questions, right? So let's say we solved this array problem 6, right? I guess we solved this one. Yes. So if you just go to the end of any question, and it's there in any platform, right? It will be definitely given. We just go to the end. There will be some constants that's written, right? You get the largest value of n for what is the largest value of n that will be there. What's the largest value of a of I that will be there? So each array, what is the largest value? What is the smallest value that's there for this? Okay, so smallest value, it's fine, right? If it is smaller on, if it is even on the smaller side, that's really causes problem. But the largest value you can see. So now see, let's say you're given n is 10 to the power 5. So will order n logic work? If big is big of n fine over here? Yes. Is big of n square fine over here? Is big of n square fine over here? N square is 10 to the power 10. There is no maybe. And 10 to the power 10 is definitely no, right? N cube, no. So you cannot write any logic like n square, n cube. These are not going to work, but order n is definitely going to work. Okay. So from the constant itself, you'll get the idea what is the kind of logic in that. So you can so if you can solve this problem using a single loop, but nested loop is going to be a problem. You should not use a nested loop. Okay. What if it's greater? So you'll see an error like time limit exceed, right? So this compiler will give you error like time limit exceed. For now, you don't have those errors because the test cases are not actually given till 10 to the power 5. So for example, if you go back and you see all the logics that you would have written, so you would have exceeded this 10 to the power 8 limit in a lot of places. But actual test case that is running is not 10 to the power 5. You will get, it will be 100,000 or lesser than that. So your logics are going to work because till now you did not know about time. So we did not put those checks. Now going forward, the questions that you will get or the questions that we'll discuss, right? We'll try to write a logic. We'll not just try to write a logic, we'll try to write the logic that is optimized and that will work on the given constants. Because from now on, the questions that you'll see, those will be working on stricter constants. And if you write a logic which is going to violate that and 1 second, so you are going to see time limit exceed more often. Okay, so the time limit exceed that you're not seeing till now will come or will occur to you more often from now on, right? Going forward in the questions. Okay. Let me show you what are the like other variations of this time. Achha. Tell me one thing. So let's write one loop. So you understood this n square n cube. This is clear, right? Order n square, order n cube. What is this time complexity, right? So it simply says this is dependent on n, this is dependent on n square, this is dependent on n cube. Okay. And apart from this, if you already know the lines of code, it is simply always represented by big of 1. Now, big of 1 doesn't mean that it is always going to run in 1 second. Okay. This you can clearly keep in your mind that because of 1 doesn't represent that something that runs within 1 second. It simply represents a constant amount or fixed amount of time. It might run within 1 second, it might run in 100 seconds, or it might run in 1000 seconds as well. Now that you will only able to know if you see the code. Okay. If the value of n is 2, then the complexity will be 2 to the power. So we don't. So we write the complexity in terms of n. We don't write it in so like if n value can be anything, we write what is the variation of it. If you already know that n value is always going to be 2, that is constant time, right? So this you write either big of n, big of 1, or big of n square, something like that. We don't write big of 2 square or something like that. This is not. So if n value is 2, that means it big of and the complexity is big of n, it simply means that your code is going to work. Okay. Achha. Huh. We saw exponential example. Now let me give you some polynomial example. Okay. Let's say you have a loop like this, order n. Okay. And then you write the same loop again. Okay. You copy this loop and you write it again. And you just write it one more time. So what is the total number of lines of code? Firstly, tell me just lines of code, don't tell me about an order n or big O complexity. It is n plus n plus n, right? So it is 3n. The total number of lines of code that you have is 3n, right? Okay. Now here it gets a little bit confusing. So listen to me very carefully. I know this is confusing and it took me like earlier used to make me also think. But this will make sense once you understand this. Okay. Okay. I'll come to what if the variable names are nm and if you are running this loops for different number of different variables. I'll come to that part. Okay. Firstly, let's do it for one single variable. Okay. So let's say this is 3n lines of code. So we represent any constant multiple. We go any constant multiple into n as order n itself. Okay. So it is like big of 3n, but we write big of 3n as order n. So because this is equivalent to order n. Okay. Now, is it valid for any constant multiple? So if I write big of 100n, does it mean we'll write big of n? Yes, we'll actually write big of 100n as big of n, right? But there is a catch. Okay. So, okay. Let's say you wrote a logic that is 100n lines of code. Okay. Now, what is the highest value of n for which it is going to work? 10 to the power 6. Right? It will not work for 10 to the power 7 or 10 to the power 8. Right? If you put 10 to the power 7 or 10 to the power 8, this is going to be like greater than 10 to the power 8 lines of code. Right? So it is not going to work for those lines. Okay. So we represent it in big O of n. Now here there is one small thing for you to understand. Big O represents those part of code which you can optimize, where you can control. If you write some constant time, so for example, if you have written this loop 3 times and you are getting a complexity of 3n, so what big O assumes is, there is one assumption that big O makes, that this constant amount of time cannot be improved. Okay. You cannot do it in like 2 loops, or you cannot reduce it. But yeah, you can reduce the iterations of this. If you reduce the n value, or if you write in lesser number of iterations, if you actually run the loop for some less iteration, let's say square root of n. Okay. Then your time will improve, but there is no way to improve this constant time. Okay. So Bigo makes one assumption that there is no way to improve this constant time, but you can improve the like n which is varying. Yes, so you can improve the varying parameter, but you cannot improve the constant parameter. Understood? So the varying parameter cannot be can be improved, but the constant parameter cannot be improved, and this is the assumption that Bigo makes. Okay, so that's why any constant into n is always big O of n. Now it does not mean that 100n is going to work. It is not going to work. Okay, I know I'm self-contradicting myself in both the statements, but it is how it is. Okay, so in representation, you're going to write it as big O of n. Okay, you say it as 10n or 100n. Okay, let me explain you this. Achha. So I'll give you clarity. Okay, I know this is a little bit confusing over here. See, so what is this number of lines of code? How many lines of code is this? This is 3n, right? Yes. Achha. Now, what is how do we represent it in big O terms? We represent it as big O of n. Okay. Now, why are we representing it in big O of n? Now you'll say if it is 100n, then also will we write big O of n? Yes, actually we'll write it big O of n, because we write generally we write any constant, right? Any constant, we generally write any constant into n as big O of n. Now, why do we do this? Any constant into n, why do we write it as big O of n? Why not something else? Okay, so why not we write that constant value? So we assume there is only one like small thing to understand over here. We assume that this constant cannot be improved, but this n can be improved. Okay, so this n varying parameter can be improved, but this constant time cannot be improved. Okay, so for example, if you're writing 3 loops, this cannot be improved, but if you optimize each of these loops to run lesser times, then your time will improve. Okay, so that is one assumption you'll make. So you'll never need to write like something like 100 or something. Achha. So just one simple thing, clarifying this. So if you get a question like this, okay, just let me show you this. So let's say your outer loop is running for 10 times and you write an inner loop which is running for n times. So what is the big O notation of the time complexity of this? So in big O terms, I'll still say that this is big O of n. Okay. In big O terms, this is still big O of n. Now, does it mean that since it is big O of n, it will work for 10 to the power 8? No. It is in actual number of lines of code, it is 10n. So highest value of n can be 10 to the power 7. Okay. So basically in big O, right, we represent the varying parameter. It does not necessarily mean the actual number of lines of code is n. Actual number of lines of code might differ. Okay. So for example, here, the actual number of lines of code is 10n. Okay. But in big O terms, we represent it as order n. Okay. So this you yourself have to take in mind that always if I just give you big O of if I just give you big O of n and I tell you that n is value is 10 to the power 8, is it going to work? Okay. It might work in certain scenarios if you have only 10 to the power 8 lines of code. If it is like 100 into 10 to the power 8 lines of code, then it won't work. Okay. So this is one thing that you can understand from here. So big O is not a representation of lines of code. It is representation of the varying parameter which you can improve in your code. Okay. So for example, here you can improve n. This will assume that this is a fixed loop and this cannot be improved. If you have written a fixed loop for 10 times, so this cannot be improved, but this you can improve. We'll assume that if you improve this, your time will decrease. Okay. Understood? So just given big O, you always have to calculate the number of lines of code to get the actual time. You should not rely on big O. Big O is just a saying convention that this is the time complexity of your code. Got it? So if I ask you what is the time complexity of this, you'll say it big O of n. If I ask you will 10 to the power 8 work for this, you have to say no, right? Because this is how it works. It is time complexity is big O of representing big O is big O of n. And the actual line of code for actual value of n for which it is going to work is 10 to the power 7, not 10 to the power 8. Okay. So code might have big O of n complexity and n will be 10 to the power 8. It's still confusing. I know this is very confusing, and this part literally is confusing for everyone, and this is the place where everyone gets confused in interviews as well. Right? Well, I don't know why programmers make things complicated. Easy rakh lete, right? We go 10 and 10, 20 and acha. Tell me actually how many lines of code is this? See, I told you till now two things, right? Two different things. There are two different things. One is time complexity and one is Bigo notation, and they two are related. So one is lines of code and one is Bigo. Okay. So there are two things. These are somehow related. Okay. Related but not exactly. So Bigo is not always represents lines of code. So for example, you may have 109 lines of code, but how do I represent this in Bigo? Bigo, it will represent as Bigo of n. If I have, let's say, n plus 1000 lines of code, okay, how do I represent this in Bigo? We'll represent it as Bigo of n. Okay. If I have like a loop that is running for, let's say, 10 to the power 8, a for loop that runs for 1 to 10 to the power 10 times. Okay. How do I present it in Bigo? It is Bigo of 1. Okay. Now, see. Okay. Now, these two are completely different cases. Here, 10 to the power 8 will not work, n value, and here, n value 10 to the power 8 will work. So, this works, n value 10 to the power 8, and this doesn't work, n value 10 to the power 8. Okay. In this constant, even though the bigger time complexity is big of 1, it does not work. Right? So Bigo doesn't give you the idea whether the code is going to work or not. Bigo is just a notation of the varying parameter of your code. Okay. So what is the part of the code on which you can improve? If we have given two options, then which one should we pick? Understood? So see, 100 n. So for if n value is 10 to the power 8. Okay. So if n value is 10 to the power 8 and you have 100 n lines of code, right? 100 into 10 to the power 8 is 10 to the power 10. So this is not going to work, right? See, for simplicity, I'll always tell you to use the number of lines of code convention. That is very easy to understand, very easy to remember, and it always gives you the correct result. Just find out the number of lines of code. If it is less than 10 to the power 8, your code works. If it is greater than 10 to the power 8, like if it is in order of 2 into 3 into, that also still works. It's not very strict. But if it is 10 to the power 9 or 10 to the power 10, or around in the range of 9 into 10 to the power 8, so it will be might work, might not work, and 9, 10 is definitely not going to work. Okay. So that lines of code, you need to know that is the approach that you should always use to find out the logic, right? In Bigo terms, your Bigo is just a denotion, or it will say that this is just a denotion to represent time, right? This just represent time. This is not the actual time, right? More than how it works, but takes more time, right? Yes, it takes more time, but online compilers are not configured on. So when you run it in your machine can wait for forever, right? So when I run this code in my machine, it waited for 5 minutes. It never told that I will not give you the result, right? It will run forever. It will just take more time. But when you run the same code, if I run the same code in any online compiler, like let's say lead code or something, after 1 second, it is going to tell me time limit exceed or TLE. If you run the same thing in Accio platform, in questions, you'll start seeing time limit exceed. Okay. So in online platforms, they will run your code only for 1 second. If you get the result within that 1 second, it will show you the result and your code is correct. It will check whether the result is correct or not. If it takes more than 1 second, then it is going to tell you time limit exceed. Yes, 100 into 10 to the power 6 is fine. So for here, in such a scenario, if n value is 10 to the power 6, your logic is fine. It is going to work. Okay. Now getting it. Only Bigo is confusing. I know Bigo is confusing. You'll get used to it. Bigo takes a little bit time of getting used to. Number of lines of code is very easy to understand. This approach is easy to understand. So you can always calculate it for now. You'll get used to the Bigo notation. I know it's confusing at the start, very confusing actually, but you'll get used to this notation. Okay. So always I'll just have to find out what's varying in my code. You have to just put it in Bigo and that's it. So here, what is varying? So the outer loop is fixed, right? 10n. So you just have to tell it as Bigo of n. So how 1000 plus 10 to the power 8 works? So it is like 10 to the power 8 plus like some constant lines of code, right? So this takes very small amount of time. So if I'm telling that 2 into 10 to the power 8 lines is going to work within 1 second, so this is smaller than that, right? So this is very small than this 2 into 10 to the power 8 lines of code. So this is going to work, right? This still works. Okay. So this is not very strict, right? I told you, right? It's not very strict. 2 into 3 into 4 into 5 into 10 to the power 8 still works, right? Around 7, 8, you'll start seeing issues, and around 9, 10, it will stop giving you error. It is definitely going to give you time limit exceed. Is there any inbuilt? There is no inbuilt function to tell us the time complexity. Okay, I wish we had one, right? Sir, 10 to the power 7 में कैसे काम कर रहा है इसने? Which one 10 to the power 7 is working? So this is going to work for 10 to the power 6 as a chat GPT. What we write in Bigo, chalo, I'll tell you. I'll give you examples of all the Bigo representation. So Bigo has very small like range of representations that you can do in Bigo. Okay, you cannot write any complicated expression like n square plus n cube or something. It doesn't allow you to do that. Bigo is a very simple way of telling what's the time of code. Okay, so Bigo is just a simple way of telling, more simplest way of telling. Okay, so Bigo just simplifies the time for you. Okay, so okay, first thing that we understood was constant. So any line, any number of lines of code that is fixed, even if it is 10 to the power 10, it is going to take, and a fixed or constant amount of time is represented by big of 1. Okay. Any loop that runs for order n times is represented by big of n. A loop that runs for n square times is represented by big of n square. N cube is n cube, and similarly n to the power 4, n to the power 5, n to the power 6, you can get the idea, right? Now, if you have anything like 2 into 3 into 4 into n, that is still represented as big O of n. Even if you have 100 into n, that is also represented as big O of n. But there, the n value for which that logic is going to work will vary. Okay. Now let me show you some more variations of this. Okay. Try to predict how many lines of code is this. Anyone can take a guess? Think how many times this loop is going to run. Sorry. Order and ignoring the constant. So let's see. So how do we calculate such things? See, so every time you get a calculation like this, what you can do is you can follow this approach of calculating, which is uh, taking values of n and checking what the I values for it is going to run. So let's take a n value as 100. Okay. Let's start with some other constant. Let's start with 10. Okay. So if we take n value as 10, what are the values for I which it is going to run? So for I equals to 1, it's going to run 1 into 1 is less than 10. For 2, 2 into 2 is less than 10. 2 into 2 is 4. 3 into 3 is less than 10, 9. For I equals to 4, 4 into 4 is 12. So 12 is not less than 10. So it is going to run for 1, 2, 3. So let me write it in something. So for 10, it is going to be 1, 2, 3. These are the values for which it is going to run. Okay. 4, it's going to be 16. So it's not going to run. Okay, let's take 25. Okay. So 1, it is going to run. 2, 3 also it runs. For 4, 4 into 4 is 16. It's going to run. For 5 into 5, it's 25. It's going to run for that. Achha. Can we write 50? Check for 50. So it's going to run for 1, 2, 3, 4, 5 runs. 25 is less than this. 6 runs. 36 is less than this. 7 to 7 is 49. 49 is less than 50. It runs for that as well. Okay. Achha. For 8 into 8 is 64. It doesn't run for that. Let's take for 100 then. It's going to run for 1, 2, 3, 4, 5, 6, 7, 8, 9. And for 10 into 10 is less than 100. Right? Now you got the idea. So I follow this approach. Just check it for 4 values: 10, 25, 50, 100. Every time you don't get the idea, you'll see some relation between them. So what's the relation between them? So let's look. What's the highest value that it gets? So this is around root n. This is around root n. This is around root n. This is root n. So we can say this loop is running for root n times, right? So at the time complexity of this, how many lines of code do we have? Big O of root n. So we write it as sqrtn. Now, can we write it as mat.sqrtn? Yes, that is also fine. If you're this is also same thing. If I would have written it in this way, you would have immediately told me, right, that this is the square root n, right? And that was easy. This was root n. You would have immediately told me, right? Easy though. This is easy to know, right? But this was a little bit tricky to know. They understood why it is root n, how it is root n. Yeah, I into I or square root, right? What is the time complexity of this one? See, I into I is root n. See, just follow this approach of take any n values and check how is the I values for which it is going to run. So when I took n is 10, so let me just write it from 1. Okay. So when I took I value as 10, so it is going to run from 1, 2, 3. If I value is 25, it is going to run from 1, 2, 3, 4, 5. I value is 50, 1, 2, 3, 4, 5, 6, 7, right? So for 100, it runs for n value 100, it runs for I equals to 10 at max, right? So how are these values related? So for I equal for 10, it is running for 3, which is root 10 approximately. For 25, it is running for 5, which is root 25. For 50, it is running for 7, which is again approximately root 50. And for 100, it is running for 10, which is again root 100. Right? So in general, we can say it runs for square root of n times. Okay. Understood? Does time complexity, it actually helps you, right? With knowing time complexity, you can exactly guess whether you're exactly make a concrete guess, right? No, it's not a guess, concrete like you can say with certainty whether your code is going to get accepted or it is not going to get accepted, whether your code is going to work within that restriction of 1 second or whether it is not, right? So that's why time helps, right? And in interviews as well, you get a constant, like interviewers gives you constant, you can even ask the constant, what's the highest value of n. So for example, you get a complete new question and you don't know what's the optimized code of this going to, whether it is going to be n square solution, n cube solution, order n solution, right? So you don't know that. So you can ask the interviewer what is the like largest value of this input going to be, right? So if the interviewer tells you like 10 to the power 6, so you immediately get the idea that n square n cube cannot be a solution, right? You cannot write to n square loop or n cube loop. That cannot be the solution, right? 2 into I. So that is how. So let me tell you this. What if I run a loop for this much time? I equals to 1, I less than equals to n by 2. What is the time complexity of this one in big O terms? So what did I tell you? Remember, big O of any constant into n is big O of n. So what is the constant over here? Half into n. Yes, you can put the constant aside. So it is half into n, right? See, it is big O of n, right? Any constant multiplied to n lines of code is nothing but big O of n. It can be half, it can be 1 by 4, it can be 2, it can be 3. In big O terms, we just represent n. We ignore the constant part. Okay. Understood? Now we cannot say always like order and code will always be having a less complexity than a n square code. See, order and code. So for example, if I'll give you an idea. Okay. So chalo, this is a good question. Is order and code always going to get less time than n square code? Let's see. So let's say we wrote a order and code and the value of n is around 10 to the power 8. Okay. So it is going to run 10 to the power 8 lines of code. We wrote a n square logic and here the value of n is 100. So how many lines of code is going to be this for the largest value of n? So it's around 10 to the power 4. It's around 10 to the power 8, which is going to give us the less time. This one. So we cannot always say n square is going to take n order n is going to take less time or order n square is going to take less time. It depends on the value of n. Right? So everything depends on the value of n. That's what Bigo is trying to tell us, that this is dependent on n, this is dependent on n square. Now, whatever is the value of n, depending on that, your code is going to work or your code is not going to work. Okay. So that's why when we have 100 n, so it is telling that this is dependent on n. Now, whatever is the value of n for which, like if n value is 10 to the power 6, your code is going to work. If n value is 10 to the power 7, 10 to the power 8, it's not going to work. Okay. So Bigo is telling simply on what your code is dependent, right? And square root is not a constant, right? Square root of n will vary, right? Square root of n varies, right? Square root of n is a varying thing. It will vary from n. Depending on different n value, you'll get different lines of code. Okay. So let me give you one more example. So you have a lot of examples like this. Okay, to solve, there are 2 assignments on time complexity. You have a lot of questions. You have to tell what is the time of each logic. Okay. So let's let me write it in this way. Okay, order n I is equals to I plus 2. So what is the time of this? Just count how many times loop is running. How many times the loop runs and tell me the time of this. Loop is running n by 2 times. What is big O representation of this? Big O of n. Right now, see, you're getting the idea of big O. Right now, as you'll use it, it will become clearer. Right, you'll get more used to writing this. I know for first instance it's very confusing. Right, if someone is like a non-programmer, you try to explain him this. I say this is the most difficult concept to explain to a non-programmer person who doesn't understand lines of code or something. Okay, you'll say that this is just like someone who has created some complicated thing. Acha. Now tell me this one. Now be careful. Try to think of this one. How many lines of code is this actually? Follow that approach of 10, 20, 25, 50, 100. I gave you approach, right? When you are not able to think of anything, follow that approach of 10, 25, 50, 100. Check how many times your loop is running. You'll get the idea. Chalo, let me explain you the approach again. See, so whenever you get a new question where you don't know, right, how to guess it, right, how to know anything, you don't get any clue. So follow this approach. Check for n value 10. How many times this loop is going to run? So what are the values? So for 1 it runs. Then I value changes to 2, right? I value changes to 1 into 2. So for 2 it runs. Then it changes for 2 into 2, which is 4. So 4 also it runs. Then I value gets updated to 4 into 2, which is 8. Then also it runs, right? So it is running for n equals to 10. The I value changes from 1, 2, 4, 8, and it works then. When in the next iteration I will become multiplied to 16, it will not work. Okay. Let's check for 25. So for 1, then it will change to 2, then it will change to 4, then 8. It is going to work for that. Then it is going to become 16, and then it is becoming 32. So it's not going to work beyond 16. Achha. For 50, it is going to change from 1, 2, 4, 8, 16, 32, and then it's going to become 64. So it's not going to work for that. For 100, it's going to be 1, 2, 4, 8, 16, 32, 64. Right? These are the only values where it's going to work. So here it works for 4 times. Here it works for 5 times. Here it works for 6 times. Here it works for 7 times. Okay, that's it. This is less than the root, right? Actually, it looks like here it is less than root. So let's just try to do a few more. So even if you don't get idea till here, you can keep on doing it for multiples of it. Let's try to do it till 500. Okay, you'll get some idea. So let's do it 1, 2, 4, 8, 16, 32, 64. Then it will run until 128, 256. That's it. Then it's going to become 528. So it's going to run for 9 times, right? So it's way lesser than the root of this. The root of this was 500 is going to be very high, right? Root of 500 will be something around 20. 20 is 424. Yes, 20, 24, 496, something, I guess. Okay, understood. So the root is like way higher. Root is 24 and we are running for 9 times. So it doesn't look like a root. So what is this value? Okay, so this is actually a log n complexity. Now, how did I get log n? So now I'll explain you a little bit about log n. Okay, how many of you know logarithms? So this is the only complicated complexity that's remaining. Last one. Okay, how many of you know about logarithms? 22 is 484. Okay, so around 22 times, 22, 23. लॉग समझ नहीं आता ठीक है चलो दैट्स फाइन ठीक है because you have not understood it in the easiest way चलो I'll tell you a easiest way to understand log. So what is logarithm? So 10 to the power let's say 2 is 100. Yes, this you all everyone understands this, right? Everyone understands this statement. So logarithm is nothing but a different way of writing power. So we write power like log of 100 base 2 is equals to 10. So we write log of 100 base 2 is equals to 10. So, or you can read it as what raised to, okay. Oh, sorry. I wrote a little bit mistake. Yes. Thanks for pointing that out. Sorry. Log of base 10 is equals to 2. Yes. Just a mistake. Yeah. Okay. So see, what we are writing is log of 100 base 10 is equals to 2. What does it actually mean? So with what power you will raise 10 so that you will get 100? 10 raised to the power what will result in the value 100? Or if you write log, let's say 1010, what is the result of this? So I'm simply asking with what power will you raise 10 so that you get 1000? So the answer is 3. Okay. So if I write log 64 base 2, so I'm simply telling what is the value of this. So that's the value of this. So the value of this is with what power you'll raise 2, so you get 64. So it's 7, right? 2 to the power 7 is 64, not 8. No, 6. It is 6, not 7, even 6. Yes. Oh, 6. 2 to the power 6 is 64. So if you raise 2 to the power 6, you'll get 64. So whenever I write log of something, right? Log, basically, let's say log 100 base 2. So with what power you'll raise 2 so that you get 100? So 2 raised to the power 6 is 64. 2 raised to the power 7 is 2 to the power 6 is 64. 2 raised to the power 7 is 128. So it is something 6 point something. If I raise it to something 6 point x by z, I'll get 100. Something around 6 point something. Yes, 6 point something. What this? So this is what log is. So basically, with what power you'll raise the base as that you get this value. That is what log is in just. Okay, that is what log asks. That is what log means. Understood what logarithm is? Now is it looking easy? It's just powers written in a different way. Nothing, no complicated mathematics like trigonometry or something. It is not trigonometry or something. It's just powers written in some different way. But that's it. Okay. Now look at this. How did we get this as log? So see, look at this observation. Okay. So what is log 10 base 2? So it is around 3 point something, 3 point something, 3 point x y z. What is log 25 base 2? It is like 4 point something. What is log 100 base 2? It is 7 point something. Yes. Now, okay, I'll explain this part. How did I arrive to this? Yes. See, one easiest approach you can think of, one easiest way, why base 2? Yes. One easiest, simplest thing that you can think of is looking for patterns of this I. Okay. जब समझ नहीं आया, ठीक है, we wrote this. So you wrote this and you did not get the idea कि what till what it is going to reach or how many iterations you are going to get. ठीक है. So if you don't understand this part, when root it was clear, right? So you just observe the first value, observe the last value for which it is running, and it was continuous. So for example, when it was root, so for 100, it was running for 1, 2, 3, 4, 5, up to 10. So okay, for 100 is running till 10 times. So if I write it as 121, it is going to run for 11 times, right? So it was fixed. So 1 to 11 times, right? Now you have to look for this pattern. So it is not continuous. So continuous to nahi hai. Now, how is this pattern varying? Just look at this pattern, observe any one of this pattern. So it is nothing but into 2. So 1 into 2, 2 into 2, 4 into 2, 8 into 2, 16 into 2. So it is varying with multiplication factor is 2. Now look at any series, it's just getting multiplied by 2. Yes. So that's why I took the base as 2 for log. If you get a spat series like this, 1, 3, 9, 27, 81, so you can take the base as 3, where this is getting multiplied by 3. So this is the easiest way to find out a logarithmic time complexity. For n equals to 50, the number of iteration is log base 250 approximately. So it's going to give you 4, 5 point something XYZ. Yeah. So it is plus 1 iterations extra. That is fine. Okay. Plus 1 minus 1 iteration doesn't vary if you are getting approximately that result. Okay. Understood. So for logarithm, you just have to observe this pattern. So just to summarize this, if you get a pattern, I value is varying in the loop, I value is varying something like this: 1, 2, 4, 8, 16, 32, 64, or 1, 3, 9, 27, 81, something like this, or 1, 16, sorry, 1, 4, 16, 64, something like this. Right. So then you can say it is logarithmic complexity. So these all are log n. These all are log n. In when we represent log n complexity, we don't tell the base, but so this is like actually if in actual term, this is log n base 2, this is log n base 3, this is log n base 4. Okay. So whenever we write log n complexity, we avoid the base. Right. So the entire point of Bigo is to simplify it, right? So if you think of base, that is making a little bit complicated. So we simply say that this is log n complexity. Okay, understood? And log n complexity is like the very fast complexity. Okay, very log n complexity is very fast. Okay, it is like just close to n, order 1. Now I'll tell you why log n is very fast. So n goes up to in log n complexity, so it will go to n, right? Almost n, right? So your final I value will in log n complexity, your n value can be very large. Dinner break, did you all not have your dinner? Are you waiting for the dinner break? So it's all right, no break. Yes, I'll complete it in 15-20 minutes and you can get your breaks. Okay. I'll not give breaks, right? I already informed that. Acha, when I initially put that message, was it not coming under my name? Were you seeing it some other name? Because I was seeing my name on Zoom and it was working very weird when I opened it on my. So actually, I was connected from mobile. Yes. Yes, someone else name. Yes, I got students replying, okay, ma'am, okay, ma'am. And I thought, ma'am, क्यों reply कर रहे? Okay. I guess there was some problem. I was seeing my name and yeah. Just manage eating in between. Yes, that you can do. But don't sleep off. Okay, don't doze off. Okay. So this is how you can observe a log n pattern. Okay, so if you have 1, 2, 4, 8, 16, something that is multiplying by this, and log n is very fast. Okay, let me tell you this. Acha, chalo. So let's say your n value is you have written a loop and n value is 10 to the power something like 18. Is it going to work? How many iterations of loop is this going to be? So this would result. Acha, take a guess. How many iterations of loop is this going to be if n value is 10 to the power 18? How many times the loop is going to run? So let's forget about 18. So let me give you some realistic number that you can calculate. Okay, let's take it as 10,000. Okay. So for n value 10,000, just tell me how many times loop is going to run. If n value is 10,000, how many times your loop is going to run? Big of log 10,000. Yes, you can tell log 10,000, but tell me the number, right? 13, not 19. See, so it's going to run for 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 4096, 8192. Yes, that's it. So it's like 10, 11, 12, 13. 13 iterations around, I guess so. Around 13 times, 13, 14 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah, 14 times. This loop is going to run 14 times. See, for n equals to 10,000, it's going to run for 14 times. And here it is going to even increase. For n equals to 20,000, it's going to run for 15 times. N equals to 1 lakh, it's going to run to some 18, 19 times. Okay. So n equals to 10 to the power, this is 4. For n equals to 10 to the power 5, it will run for around 18, 19 times. For n equals to 6, it's going to run around for something 24 times. For n equals to 8, it's going to run around for some 25, 27, 28 times. Okay. See, for if n value is 10 to the power 8, the loop is actually run for just 26, 27 times, right? Very small number, right? 26, 27 iterations, 26, 27 lines of code. So small logic, right? So log n is very, very fast complexity. It is one of the fastest complexity that you have after the constant complexity, obviously, right? A constant time, and then you have log n. Log n is a very fast complexity. If you are able to write any logic in log n, that is way, way faster, okay, than anything like root n or order n or n cube. Yes, binary search has a log n complexity. Yes. So binary search has log n complexity. Okay. So in searching also we get something and log n complexity, which is also very fast, really close to order n. Okay. So I'll write the complexities in order. So since you saw them, so the okay, and then you can have exponential complexity. You can run a loop for 2 to the power something. Okay. So this is like the worst complexity to have. This is like 2 to the power something, 3 to the power something. So this is like one of the worst complexities to have. Okay. So there are like a lot of ways to get this 2 to the power n, right? Not just by writing a loop that runs for 2 to the power n. There is other ways, like in recursion also you get a exponential complexity, and those are very bad. Factorial is also bad. Now I am exactly cannot recall. So we can compare it. Factorial is, I guess, better than exponential, this one. So the worst one is exponential 2 to the power n. Factorial is a little bit better than this. Okay, so n factorial is little bit better than this. Okay. Then you have polynomial complexities like n to the power 4, n to the power 3, n to the power 2, then order n. Then from n you have better is square root of n. So if you can like optimize something from n to root n, that will be better. And if you optimize anything to like log n, that is way better. And then finally you have like constant. So I don't write it as constant, is not written over here, because constant does not tell you about time, right? So constant time is basically not a denotion of number of lines of code. Okay. For the last question where we gave us n is 10,000, what's the way? So log base 10,000 is around approximately 40, right? So it's 40. So log n, so it is going to be 14 point something. So log base to 10,000, it's going to be 14, 13.14 of 0. So this is 0. So this is 13 point something. So it is like 14 lines of code, right? So it is 13 point something, I guess. Okay, understood? Understood the time complexities, their order, and these are the only complexities that you have. There is no other like polynomial that would come up. There is only one thing that you have to, one last thing. If you understood this, I can tell you the last one. No interviewer is going to ask. That's why I told you, right? In interview, no one is worried about whether it is 13 or 14 lines of code. That is not a problem there. The only thing that the interviewer asks is, can you tell me the complexity of it in big terms? Okay, you can simply tell it is big of 1, big of root n, big of log n, big of n cube, big of n square. Okay, that is the only thing that he asks. Any interviewer asks. Okay. Okay. N factorial is greater than 2 to the power n. Now this is like you can validate this. Okay, let's check it for smaller input. We'll get the idea. So let's take n is equals to 10. So 2 to the power 10 is 1024. 10 factorial is so 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8 into 9 into 10. So this is definitely going to be larger than 1024, right? Obviously, but check for 2 to the power 100 and 100 factorial. Which one is going to be larger? 2 to the power 100 is 100 multiplied. Yes, so factorial is larger. Yes. So this is anyways going to be larger. Yes, you can write it as this way. Or n factorial is larger than this. Or easier way to approach is this. Easier way to think is this. Yeah. Okay. So you can think it is like this, right? N factorial is like 1 into 2 into 3 into 4 into 5 into something like this, right? But 2 is just 2 into 2 into 2 into 2 into 2. So these are less than, right? So these values are less. So anyways, this product is going to be lesser and this product is going to be larger. But this is not going to hold true for any exponential thing. Okay. So for example, if it is 3 raised to the power n, 4 raised to the power n, 5 raised to the power n, or 10 raised to the power n, then there might be some point where it would be like going to larger. Yeah, for a smaller number, like 2 to the power n or 3 to the power n will be lesser than n factorial. Okay. So n factorial is the worst one, right? Which you won't have any logic which is having n factorial. You won't even have this for now. Okay, this is going to occur when you write like recursion and that logic, and there we'll understand about how we can optimize this. For now, you are going to be working on these complexities. Okay. Now, first you tell me, understood this part? Yes, is this clear? Then I'll tell you about what's the next last thing in this. Now, these are the only complexities that's there. Now you can play around with it. Like there can be addition, subtraction, multiplication of these complexities. So for example, let's say I write an outer loop of order n and I write an inner loop of root n. So what is the time complexity of this? So outer loop is order n, inner loop is root n. So this is n root n, right? Okay. So this can get multiplied. Similarly, if I write outer loop of order n and inner loop of log n, so what will be the complexity? So let's say I write this, and inner loop I write j is equals to j into 2. So this is n log n, right? Okay. So now this will get multiplied. Okay, so that's clear, right? If you write a combination of this, that gets multiplied easy, right? So this is n root n, this is n log n. Okay. Now, when it gets added, so if you have two different loops, so for example, if I write it as this, let me paste it over here, write it as 4. So what is the time complexity of this one? We are multiplying I into I, but the condition we are checking is less than n, right? So here we are multiplying j into j, but we are checking less than n. So if you take the actual values, you will check if n is 100, your loop is running for 10 times, right? So it is how many times loop runs and how it varies with n. How it varies with n. So that's what we check. Okay. See, so it is n plus root n. Here it is n plus root n. Now, whenever you get an expression like this, so let's say you can write a loop that is like that runs in n square. Then you write a loop that is running in order n, and then you write some fixed lines of code or some 2n lines of code. Okay. So this is like or some log n lines of code or root n lines of code. You write a logic like this. So your sum is this. Now, since it is not nested, so you just take the highest order of from them. Okay, you just take the highest order and your time complexity for this logic is big O of order n. Okay, this is big O of order n, because the highest complexity between order n and n square is order n and root n is order n. Okay, so just pick the highest complexity of it. So if you are getting an expression like this, okay, understood? Yes, no. Okay, so you can multiply them. When it gets multiplied, it is normal multiplication, n log n, n root n, n square into n, so that will be n cube, right? X 2 to the power n into n square, 2 to the power n log n, that will get multiplied. Huh. Not understood? I2 I less than I is equals to I into I. Okay, so let's check for this, and there is one interesting question. That is also possible. Order n into log n into root n. That is also possible. You need to write three nested loop. One is order n, one is log n, and the last one is root n. Fill up. Okay. Okay, sorry. Uh, okay, see. Dekho. So when it gets multiplied, right? When it gets multiplied, so then it is fine, right? Let's see, you can multiply any possible combination, that is fine. When it's get added, that time you just have to tell the highest order of them. Right? So if you are adding n square and root n, the highest order is n square, and that is going to be in your big O complexity. Right? Why? So why do I tell the always the highest order? Why can't we tell big O of n, big O of root n? See, no matter how much you optimize these part, big of order and big of n square, this is going to cause the time to always be in your logic is not going to run until you optimize this one for higher values. So for example, if your n value is 10 to the power 4, right, no matter how much you optimize this is going to give you 10 to the power 8 lines of code, right? No matter, let's say if your n value is 10 to the power 6, no matter how much you optimize these two parts, if you don't optimize this, your complex total number of lines of code is going to be 10 to the power 12, which is not going to work. Okay, so you have to work on optimizing the highest order term. That's why I just represent this in the big O, and we don't represent this ones in the big O terms. Okay, understood that? Achha. Now there is an interesting question, good question in the chat. Let's pick this. Okay, so let's say we have int I is equals to 2, with go till n, and we have I is equals to I into I. Now what is the time complexity for this? Now this is completely new. How do we check this? So just check for the first value of I is 2. So check for 10. Then I changes to 2 into 2, which is 4. Then I changes to 4 into 4, which is 16. Then I changes to 16 into 16, which is like some exponential of 16. Okay. So it is not going to, it is going to run for only of 2 and 4. It's not even going to run for 16. Let's try to write the I values of how it's varying. So it varies from 2, 4, 16. Then it is 16 into 16, which is like whatever is the square of 16. Like, is it 256, 296? 13 is 169. 14 is 200. 14 is 196. 15 is 225. 16 is 200 something, 256 or something like that. Okay. Then this into this is going to be even larger. So this is a very small time, right? I don't think we have a like, yes, 256. Okay. I don't think there is, then it is going to be even higher. So how do we represent this? So what's the mathematical symbol that represents this relation with n? So this is like very close to, I'll say, ki constant time. This is like whatever value, even if it is n is 10 to the power 18, or it is not going to run for more than 10 times. It is not going to run for more than 10 times, even for this. So you can treat it like a constant time. There is no representation of this in Vigo terms. You can treat it like a constant time because this loop is going to run for at max 5-10 times. Okay, very small number, 5-10 times. Even if n value is 10 to the power 18, over 10 times से ज़्यादा run नहीं करेगा. Okay, I don't think we have a way to represent it in Vigo. There might be, but I am not aware of this. Okay. ठीक है, I'll look into it if there is any way to represent it in any mathematical way. Then why the complexity is 10n for I less than 10 and j less than n for two loops? I don't get that question, but there are no need of tell higher term. Yes, so you just need to check the higher term and it should not other terms doesn't very matter. Hina, I did not get the actual question. So if the complexity is 10n for I less than 10 and j less than 10 n for two loops. So we represent it as order n. If it is any multiplication of n, we just ignore that constant term, assuming that it is like going to be it cannot be changed. Okay. Is it n to the power n? No, it's not n to the power n. N to the power n is different, right? Where you have order n loops within n. So that is n to the power n. This is like reverse of that. Right? It is n to the power n ka reverse. It is going to exactly run for what it says your powers are increasing in exponential terms, right? Your in value is not going to be that, right? So n to the power n is very bad complexity, right? But this was actually very good complexity. This is actually a very good complexity. This is even way faster than log n. This is somewhere between log n and order one, constant time, right? It is optimized than log n. But yeah, I don't get that exact mathematical term. Right. I got the now the last part is what if the variable names are different? I'm getting that question again and again. What if the variable names are different? How do we represent it? Just represent it in order n into m. Take or n plus m. So for example, if you have, let's say this is n and this is m. So how do you represent? So let's say this is a n square pe chale jate. Okay. Let's go to the previous one. Lines 4. Order n square root of n square. This is n square. So what if this is n and m? We just tell it as order n into m. Okay. What if it is n, m, and o? So we tell n into m into o. Because of n into m into o, all the variable terms we write it. M is a variable term, so we write it. Okay. So n is a variable term, so we write in n into m into o. So if there are multiple variables, you write it. So what if you write two loops of order n and this is order m and this is order k, let's say. Okay. So how do you represent this? So this is big of, do we represent it as big of o n? No. This time we tell it as big of n plus m plus k. Okay. This is the only place where you'll see addition in big O complexity. Okay. Inside the complexity, it is big of n plus m plus k. If you have a loop, right, big of which is running for big of order n, big of order m, big of order k. Why? Because these three are variables and we don't know anyone's value. Now this is just the sum of this, and whichever is the highest value that will take the thing, right? What if they have different powers? Yes, that if they have different powers, so let's say n will be n's highest value is 10 to the power 3. This is 10 to the power 6, and this is 10 to the power 8. Okay. If you know this, so this is like this loop is your bottleneck. This is going to be 10 to the power 8, and this is going to determine your time. Okay. These loops are very small time as compared to this one. Agar n, m, and k all are constant values, if their values are fixed, let's say n is 1000, k is 500, and o is, m is 1500. So if they are constant values, then it is then it is big of 1. Agar ye constant values hain always, then it is big of 1. We take the largest here, but we don't know the largest, right? We don't know the largest. So we represent it as big of m plus n plus k. So we represent it in all variable terms, right? So be variable code, right? Whatever is the variable terms in the logic that we represent. So if it is big of n square, so we tell it big of n square, right? We know what the highest value of n can be, but we tell it as big of n square, right? So here the variable terms are n plus m, n, m, and k. And how they are related? They are related as sum. If it was nested, so we'll say n into m into k. Similar like telling n cube. Okay. So we just tell it in that. Okay, understood? If k has largest power, like if k is the highest value, if you know that it is k is the highest value among all of the three, so you can say it as big of k as well. Okay, because these two are going to be lesser always, and if this is the highest one, so you can say it as big of k. Okay, see, big of constant time is basically big of 1, which tells that the time is constant or time is fixed. You cannot change anything in this code to get it running in a lesser time. Okay, so basically if you write a logic like this, each line of code, this is like whatever machine takes that it is anyways going to take. You cannot change this, you cannot improve this. If you write a loop that is running for constant amount of time, because assumes that there is no way to reduce the number of iterations over here by decreasing n value or by writing something better logic on it. If you have written some loop like or some lines of code, so this is going to take some fixed amount of time. Now that is known as constant or fixed amount of time. It may run within 1 second, it may not run. Okay, so any logic which cannot be changed by any bearing any n or something, that is known as fixed amount of time. So here when I say is n, big of n or big of n square, I mean that this logic is dependent on n's value and it is going to run for certain values of n and it is not going to run for certain values of n. Okay, so that's what we mean when we say big of dependent on n or n square. Understood? But if two n's and one m loop, so we write 2n plus m, we can simply write it as n plus m, right? So 2n is equals to n, right? So you can write n plus m. In that scenario also, you can write big of n plus m. Okay, so simply remove the constant part from there. In the question, we are given an n for array length when we find it using it. No, n is given you just to like we can find it using array.length, but since it is in order to take input of user in form of array, we need to know the length of array to run the loop. So that's why we need to ask the user, and that's the only reason we already have the n value, and it is passed to functions as well. Okay, but you can pass it. Sometimes you'll see in some question you have just passed with array, and you need to use array.length to find out the length of the function. Okay. Okay. Now this is a good question, sir. Still, now this is a very good question. It'll take 1 minute to answer this. So in actual development scenario, so this is like all the theoretical things that I taught you about today about DSA, right? How will you measure code right now running on a compiler that 10 to the power 8 is a constant that you follow? Now, does this all things actually are followed while developing softwares, or we forget all these things and we write our logic? And in actual software, the code is way bigger, right? So for example, the Windows code is more than 50 million lines of code. Okay. There are a lot of software, like for example, the Office suite, right? So there is an Office app which supports your Microsoft Word, Excel, PowerPoint, Loops, OneNote, or any Microsoft product that you have, like OneDrive. Everything you can open in your office.com site. If you just visit office.com, you can open literally anything there. Okay, so it supports all the different platforms that's there. Now that code is like integrating so many different lines of code. Excel code itself is so large. Outlook code is itself so large. Windows itself is so large code. Now, does this actually, so how all of these softwares are working, right? Does it take 5 seconds, 10 seconds, 100 seconds to run this logic? So much lines of code. So see, actually, all the code doesn't run in a software. When you will develop software, all the you might have written 10 million lines of code, but all the lines of code is not going to run. Google search is having 100 million lines of code, let's say, but when you type something on search, all those 100 million lines of code doesn't run. Out of those 100 million lines of code, there is some the 1,000 lines of code that runs for in order to give your result or in order to perform the operation that you are doing. Okay, so there is some small portion of code that's going to run, and we just have to ensure that whenever this code runs, that particular portion runs within 1 second. Okay, that is the thing that we ensure. Just like React component, yes. So if you are familiar with front end, so in front end you create React component. So you just have to ensure that whenever user performs this button click, that clicks works in within 1 second. Okay, you don't have to ensure that every other thing in the site is also getting working in 1 second. You just have to perform for one action. So one user interaction, one particular action, one particular logic that you are written that works within 1 second, and that is still going to be valid while you develop software. There also this concept is going to be used. Okay, got it? Okay, so this is all about time. Don't worry, like for now, if we the Bigo complexity is little bit tricky at places, you can use the number of lines of trick. That is going to work always. You just have to check whether your number of lines of code is less than 10 to the power 8. It's going it works. If it is greater than, it doesn't work. Okay, the other thing that you can keep in your mind is you can represent things in Bigo. Okay, so this is like the common convention. So if I ask you what is the complexity of this, the answer is Bigo of n square. Okay, so the complexity measurement, we assume that it is going to be stated in Bigo terms, and from that we derive whether this logic is going to work for certain value of n or certain value it's not going to work for certain value. Okay, now let me just go through a few of the example questions. Okay, let's not start with other things today. Okay, I guess do we have time? So what are the other thing that I mentioned to start today? क्या थे? So diamond pattern sub array array part, right? ठीक है, so we'll complete these two tomorrow. ठीक है, ये तो कर ही लेंगे कल, अब कर ही लेंगे. अच्छा, how many of you have doubts on diamond pattern? ये solve नहीं हुआ, कितने लोगों से solve नहीं हुआ? How many of you have doubts? I want to know that number. Is there a lot of people have doubts on this one? Yes. So if you have doubts, you can tell me, right? No problems, right? If you have doubts, that's fine. ठीक है, चलो okay, so ठीक है, we'll take it up. Yes, there is only one test case wala thing that's there. So ठीक है, we'll explain this tomorrow. You will also cover the subarray wala parts. We'll explain subtraction, addition, and subarray concepts. Subarray is not a very like a big thing. It's just a small thing. There is one question that I want to solve there specifically, which will show you a lot about time optimization. Now, since you know about time, that question will be very interesting. How many of you know about this thing, cadence algorithm? Have you ever used this? Have you heard this thing? This is one of the most asked question in interview, right? This is one of a like I'll say ki, you get you get a direct question on cadence algorithm to write the logic. No one is ever like able to guess that this is a cadence algorithm logic. Okay, but you get it as direct question. There is no variations that you get. Very rarely you get some variations of it, some wording of it, but most of the time it's a direct cadence algorithm question. Okay, this is going to be a very interesting discussion. I'm going to discuss this and some subtraction, all these things tomorrow. We'll complete it, and then we'll start with today rest, day after tomorrow. Okay, so yes, this week we are going to complete this. Today is Thursday, Wednesday. Today is Wednesday. Okay, we have time. It's a normal concept. There is no dynamic programming. Theta omega, it's for now I'll not cover that. We'll cover them somewhere later. For now, you don't require this. Just I'll need to explain you some graphs and some time space. Till then, I just want to use it Bigo. We'll get used to it. I'll explain you theta and omega. Okay, so this is theoretical, same like Bigo concept. So I don't want you confused now. So use Bigo for simplicity now. You will be easily able to understand theta and omega. Not it won't take more than 15-20 minutes to explain this. Can you give hint on array subtraction for negative number? See, so when you're adding array, addition is easy, right? But on subtraction doesn't work for a larger. So you cannot subtract a larger value from a smaller value. For example, you cannot do this. This cannot be done. Okay, there is no way you can subtract this. So if you get a situation like this where first number is smaller and the second number is larger, what you have to do is you have to actually subtract the smaller number from the larger number and add a minus sign in the start of it. Whatever result you'll get, you'll add a minus sign to the start of it, and this is your result. So you just have to add a minus sign in the very first index. How do we get to know the greater number? Now that's a valid question. If I tell you this, okay, so you say this, how will we measure which number is greater? So this in itself is a question. So let's say you are given two array representing a number. So let's say this is a array and this is another array. So which number is greater? So the number having, so if there are two arrays of varying length, so whichever array has a higher length, that number is greater. Okay. So any array having a higher length is a larger number. Okay. So there can be like this is array of 4 size, this is array of 3 size. So this is a higher number, right? So if the array length is higher, then that number is higher. What if the array length is same? What if I give you two arrays with the same length? So if I give you two arrays representing numbers, the array with a higher number is higher. Higher length is higher. But if let's say I give you the array with same length, you can check the 0th index, but there is one catch. What if these numbers are like this? The 0th index are same. Even the first index is same. Even the second index is same. So which number is now greater? So you need to compare each value. So if the array lengths are same, if the length is same, what you need to do is you need to keep on checking until you find an index where the numbers actually vary. So you need to write a loop so that you keep on checking each index value until you find the index where the number actually varies. And once you find that index, then you know which one is a larger, which one is a smaller index. Which one is a larger number, which one is smaller. If all the index matches, then both the numbers are equal. If the length is same and all the index values are matching, then you can finally say that the numbers are equal. Understood? Then there will be too much loops. Yes. Now, how to write this code in the cleanest way? Try to write just a solution for now. Don't worry about how clean the code is. I'll tell you how to write a clean solution for this question. Okay. For that, I'm there, right? I'll explain you how to write a clean solution for it. For now, you just write a solution for this. Okay. Your solutions will become cleaner over time. Don't worry on that. But first approach should be get a solution, then you can improve it, clean it, how it will look better, that you can work on. Okay. Understood? Hope this like the time is now clear. One more question. Array rotation done on Accio, but on lead code it's not working. So we'll check this. I guess I also did the array rotation question, right? So did you try my solution? Is it also not working on lead code? हाँ चलो ट्रिपलेट वाला कर लेंगे. I guess triplet is error. चलो but let me just check this, right? Let me validate this. So triplet is very easy. Yes.
Sir, I have pasted a question in the chat. Can you please clarify that?
Yeah. Just a second. So I guess let me first check it. Triplet, I guess everyone is facing error. I guess I remember this was an error on this question itself. Some test case should have been corrected by now. Let me check. Okay. So you have to find out a triplet such that what's the answer? You have to find out such triplets such that their sum is equal to something, or geometric progression. Okay. Let me first validate it. I'll explain it. Just a second. Agar question ही गलत हुआ, then there is no point of. He gets submitting successfully, right? I remember it was corrected. I can't exactly recall whether it was corrected or not, because I remember doing it with the last batch. वहाँ पे issue था, but then it got corrected. So let me check this. Let's just quickly validate it. ठीक है ठीक है, it's fine. It's question is correct. Question is correct. Okay, so let me explain you the approach. ठीक है, चलो, I'll tell you the approach. Now you all try the solution. The question is correct. Okay. See, so what's the triplet question asking? So in triplet, you are given an array. Okay. So for those who understood the solution, you don't need this explanation, but okay, I'll explain this. So let's say you're given some array, some random numbers in the array. So what is a triplet? So how is a triplet defined? So you have to find triplets such that they are in a geometric progression. Now what is a geometric progression? So geometric progression is a progression in which there is every number is basically some multiplication of it. So for example, you are multiplying 3 into 2, so you get 6. You multiply 3 into 6, you get 18. So basically we call it as a common ratio. You divide 6 by 2, you are going to get 3. You divide 18 by 6, you are going to get 3. So this is the common ratio. So this series we call it is in a geometric progression. What's the next term of this going to be? So it is 18 into 3, whatever that number is, 54. That is your next number in the geometric progression. Okay. Is there any other progression? So yes, there is another progression which is known as arithmetic progression, where you have a series like this, 1, 2, 3, 4. So this is in the arithmetic progression where the difference between any two consecutive numbers is same. So 2 minus 1 is 1, 3 minus 2 is 1, 4 minus 3 is 1, 5 minus 4 is 1. So that is 1. So if we call as common difference, which is 1, here we call as common ratio, which is here it is 3. So for example, this series 1, 4, 7, 10, this is a series which is in arithmetic progression. All the numbers differ another by the value 3. Okay, so the common difference is 3. So this series is in a geometric progression where the difference between any two consecutive numbers is a fixed value. This series is known as a geometric progression. So this is arithmetic and this is geometric. Okay. So here the ratio between any two consecutive number is fixed. Here the difference between any two consecutive number is fixed. Okay. Understood arithmetic and geometric progression, what it is? I can explain you the next part. Yes. No doubts. Okay. Now, what you were given is you are given a list of array of numbers, and what you have to find out whether you have to find out 3 such numbers which are in geometric progression, and how many such triplets are there. You have to print them. Okay. So how can you print such triplets? So let's say you are given this array. Okay, ऐसा कुछ है. So for one, what you need to do is for one you need to pick 2 numbers. Okay, so let's say I keep one as fixed and I try to find out 2 other numbers. So what are the 2 other numbers? So let's say I pick 2 as another number and 3 as another number. Okay. So 2 is another number, 3 is another number. So I pick 1, 2, 3. Are they in geometric progression? How can I check? So if I divide 3 by 2, whatever is the common ratio that's coming out, that should also be the common ratio that should be equal to 2 divided by 1. So 3 divided by 1 gives 1.5, 2 divided by 1 gives 2. So this is not in a geometric progression, right? Acha. So if I, instead of taking this, if I take 4, is it in a geometric progression? Let's check. So say first number is 1, second is 2, third number is 4. So on dividing 4 by 2, we get 2. On dividing 2 by 1, we get 2. Yes. So 1, 2, 4 is in a geometric progression. Okay. Understood? So when it gets more than triplets, then there is a generic way to find out whether it is what's the geometric progression. So for every number, we'll find out what's the other common ratio that we can take. So I'll explain that part first. Let's complete this one. Okay. Acha, so we pick any three numbers and then we check okay whether it is in a geometric progression or not. Then we pick this. So first number is fixed, second number is fixed. We keep on varying the third number and check whether this triplet is there in the geometric progression or not. Right. For third number, we vary it here and then we vary it here. For the okay, once we are in this loop, then we vary the second number. First number is still fixed. We vary the second number is here, and the third number keeps on varying like this. Okay. Now I told you what a geometric progression is, how you can check if something is geometric progression or not. You just need to figure out the condition. Okay. What your if condition is, how you're going to write your loops. So figure that out. You have a solution. Congratulations. If not, we will discuss it. We'll tell you the solution. Find out 248. So 248, let's check. So 4 divided. Yes, this is a geometric progression. This is a valid geometric progression. So you'll get this as the result as well. 248 will also be a result. This is a valid geometric progression. Yes, I'll explain the code of this tomorrow. I'm just giving you hints today. Okay, I'm just validating whether it's correct or not. The question is correct. The logic is simple. First, it is understood geometric progression, right? So the logic is plain. You have to fix one number in the array, and then you can keep on varying to get the next numbers, and next numbers. And one you have to figure out which number is going to give you the solution. Right? If that satisfies the criteria of being in a geometric progression, which is they have a common ratio, which is same, right? Which is this. If you divide the third number by second number, and you divide the second number by first number, your ratios comes out to be same, then it is in a geometric progression. Okay. Some are passed, some are not. Check whether you are handling it in. So the common ratio can also be a decimal number. So for example, this is okay, let me tell you this. So let's say this number is 2. This is, let's say, 5. 5 and then 10. This is 12.5, let's say. So is this a geometric progression? Yes, this is a valid geometric progression. See, because 12.5 divided by 5 is 2.5 and 5 divided by 2 is 2.5. So they have a valid common ratio, right? So this is a correct geometric progression, right? So your common ratio can be in decimals. So here the given numbers are in integers, but your common ratio might be in decimal. That also you have to take care of. Okay. Now, how do we find out instead of triplets, if we have a normal series of GP, how do we find that out? So I'll tell you that. Okay, chalo, we'll cover that tomorrow. I'll tell you that how can you find that out. Okay, understood? Okay, so take care of this scenario. If now numbers are even, your common ratio can be decimal. Okay, so for today, try to solve all these MCQs at least. Now those MCQs will be super easy for you all. Okay, just try to check this MCQs. So you have 2 MCQs assignments. So complete them. Okay, there is one coding assignment. So this is easy. This coding assignment is going to be very easy. Natural number sum, right? Find the count of digits of a number, sum of an array. All these are very easy questions. You can easily solve it. There is one. This is like the MCQs that's there. Solve this MCQ. Loop time space complexity, and there is one more MCQ. Yes, this one. So these 2 MCQs, you try to solve them completely, and try to solve this one. So you have some questions as well. So try to complete them today. Whatever is the array questions that's remaining, that we'll discuss tomorrow. We'll try to complete all array related questions tomorrow. Okay. And I explain you guidance algorithm as well. So tomorrow we'll have 3 hour like proper class. So there we'll complete all of them. So we already discussed largest buildings and all these questions we discussed. Only thing that's remaining here is addition, subtraction, right? So those 2 questions I'll discuss, and in 2D array 2, there might be few doubts that you have. Okay. So we'll discuss that. MCQ submit हो गया. So like you can try to solve it again. I don't think there is some restriction you cannot solve it again. Is there anything that you cannot solve this again? try to just inform your like batch manager, reach out to him that this is like solved my mistake. Can I access them again? Okay. So just try to get in touch with him. He will be particular person to help you out. Okay. Okay. Understood? Clear? Okay, I hope you learned about time. Now you have better clarity on time and space. Will understand. Space is very easy part. For now, focus on time. Space is like actually space is a small part that I'll cover. Okay, time is important. Okay.
Sir, yes, sir, please clarify that that question I pasted in the chat.
Which one the like for
So that MCQ one.
I into I.
No, sir, it's based on the time, it's space complex.
Can you paste
It's
it?
an assignment question.
I'm able to find it. Let me look for it. I did not get that. Can you paste it again, please? Because I'm not able to find that solution. Okay. So, okay, got it. So there is an algorithm X and Y have a worst case running time of order n and log n respectively. Therefore, algorithm Y always runs faster than X. Algorithm Y always runs. No, this depends on the value of n. Cannot. No, the correct answer is depends on the value of n. I think it should be
Yeah,
option.
yes.
Yes.
Yes, sir, but it's in the assignment, it's written false. That's why.
In assignment is written as false first case. I know completed. No, runs faster. No, it depends on the values of n. Is it written false? Okay, chalo, we'll check this tomorrow. We'll discuss assignments. We'll check this whether it is written. It depends on value of n, right? Because if n value is let's say 10 to the power. Okay, let's check. Let's have a look. So it is order n and this is log n, right? So let's say n value is 10 to the power 20 for worst case x and y. Is n values okay? Let's check. Would have two algorithms x and y worst case running time complexity of order this and this. If we are comparing both on same n, right? If the n is same for and we are comparing. Let's say, for example, if n value is same for both the complexities, like order n and l log n, then obviously log n complexity is faster than order n, right?
Yes, sir, but in that case, the answer should be true, na?
If then algorithm y is always faster than x. Yes, in that
If
case.
the value, if the value is same, then the answer should be
If
true.
n is like same for both the cases order n and log n, then always y is faster. That is true. Yes. So this question is anyways wrong. Yes, if it
Yeah.
is false, it is wrong.
Okay, thank you, sir.
Okay. Any more doubts? Anything else? Okay. So thank you everyone. You can solve all the assignment. This we'll discuss array questions remaining part tomorrow, and we'll complete all this arrays and time space discussion tomorrow. Okay. Thank you
Sir,
everyone. Yes.
Sir, share the online GDP link, sir.
Yes. I'll share it. I guess from now on you have like this thing set up, so you will receive the link in your Slack by your batch managers every day. So I'll share it in chat. For now, you can get it from here. Just a second. Yeah. Okay. Please copy this link. Otherwise, when the Zoom call ends, this would get erased. You can't access this. Okay. Thank you, everyone. Good night. Bye bye. See you all tomorrow. Take care.